So in this section, we're continuing our discussion of probability, and we're going to look at a few other ways that you as a manager can begin to make probably better decisions knowing some of these things about probabilities and events. The probability of an event is equal to the sum of the probabilities of the sample points in the event, or the elements of interest. We can identify all the sample points of an experiment and assign a probability to each. Then we can compute the probability of that event. So let's take a look at what that might look like. Intuitively, you understand, of course, that the probability of an event is just the number of ways that the event could occur divided by the total number of outcomes. So the probability of an event is going to take this form. Think of it as selecting a deck of playing cards, a standard, say, poker set of playing cards. Intuitively, you know that there are 26 red cards. So the probability of you selecting any one red card out of 52 is 0.5. And intuitively, you know that because the other cards are black cards, so you couldn't possibly be choosing red. Similarly here, what's the probability of choosing an ace? Well, there's 4 aces in a standard poker deck divided by 52. So you have about an 8% chance of selecting an ace when you have available to you all the cards in the deck. So all you blackjack players out there, you probably know this very, very well. Now, key probability terms to understand and keep in mind: an event is going to be a collection of possible sample points or experimental outcomes. So if we're flipping a coin, we saw that it was going to be one side of the coin or the other. Selecting from a deck of poker cards that has 52, we just saw, those are the events. The events are the occurrence, like ace or red. A simple event is going to be a single characteristic of that event or outcome. And again, so simple event of ace from that deck, 4 out of 52. And a joint event is where we have 2 characteristics or an outcome. So here you have a red ace from a poker deck. So it's a combination of 2 things, or a joint event, because it's both an ace and it's red. So now it's even harder to get one of those, and we know that if you're a card player at all. So 2 out of 52 versus just selecting any old ace where there's 4 out of 52. The complement of event is going to be all the outcomes that are outside of that. So in the case of, again, the cards, all cards except red aces. So in a poker deck, it's going to be all the other, there's only 2 red aces in the deck. 50 out of 52 would be, say, the complement of the event. So these are just some terms and have in mind that you'll see in the literature and in the text or other things that you might read about it. So how do we assign probabilities? There's 3 methods that we're going to be looking at today. The first is going to look really familiar based on the prior session we just had. Then we're going to look at relative frequency, which I think is one of the more useful, as well as the subjective method to actually calculate probabilities based on judgment. So look at these 3. The classical method, we've been actually exploring that already. When we started out looking at the coin toss, this would be an example of the classical method because it just assumes an equally likely outcome. So a coin flip, either going to come up one side or the other, 0.5, 0.5, 50% of the time. So this is a classical method. Roll a die. If it's a fair die, all 6 numbers could come up, 1 out of 6 for each number to appear. Or winning the lottery. We saw in the different combination rules, product rule, for example, here, winning the lottery, you must guess each number selected in order from a jar. So you have, in this case, you'd have 50 available each time. What we're doing here, we saw this number when we were looking at the different rules. The difference now, rather than just looking at the number of different possible combination of outcomes, as we did with the product rule, we're saying to win, you have only one option, and therefore the chance of winning is minuscule. And again, that's why a lot of people don't actually play the lotteries because they look at this and say, oh, the chance of winning is incredibly small. And then, however unlikely, oftentimes 2 people win, and then you're actually halving the prize. But anyway, let's move on. Relative frequency. Observe this data from an actual sample or maybe some historical knowledge that you have. So here's an example. The event is the number of days that a product has sold in the last 30 days. And the probability is going to be found by dividing the frequency, the number of days that certain number of units sold, by the total frequency, total number of days. So let's look at this example here. I'm selling iPad Pros, and in the month, 30 days that I've observed this, I saw these outcomes. I sold no iPads 4 days in the month. And if I take then 4 and divide that by 30, the probability that I would sell 0 iPad Pros in the month is actually 0.13 or 13%. Going on, 1 iPad sold on 5 days in the month. So this is the event, this is the number of days that it occurred out of 30, and so I can convert that. If I divided up 5 by 30, the probability is going to be 0.17 or 17%. So in other words, 17% of the time in the month, I'm likely to sell 1 iPad. So intuitively we understand this, but it's also really helpful to see that relative frequency, which is pretty easy to get out of SPSS. Not only is just a report out on the occurrence of some kind of an event, but you can also think about it as a probability because it's summing up to 1.0. And as you're seeing those frequencies in SPSS, another way of looking at that data is to think about it as a sense of probability. And if you were to begin then crunching your data by looking at the combinations of different categories, you're actually going to be able to think about it in terms of probability of some kind of an occurrence or an event. So here's the interpretation that I just verbally said, but just so there's no mistake about it. If I was just looking at the occurrence here of 0 iPads selling 4 days out of the month, which is 0.13, the probability of selling 0 iPad Pros in the month is 13%. Another example, if we look at the probability in terms of customer age segments, here we're looking at the frequency of things that were sold in thousands to each segment, customer segment, in a whole year. And we can still convert these to probabilities using the relative frequency method. So here we have customers in the 0 to 19 age group. They've purchased from us 19,000, let's say, iPad Pros in the year. And so what's the relative frequency of that occurring? Well, if we take the 19, divide it by the total sold in the year, which would be 179,000 units of iPad Pros sold in the year, I can actually convert that to a probability of 0.11 or 11%. So this is equivalent to saying that 11% of the time I'm going to be selling iPad Pros to customers in the 0 to 19 age group. And that would continue on. I haven't got the math here, as I believe it's intuitive. I guess I did one more here to interpret this. In the 20 to 24 age group, we sold 30,000 units in the year. Divided by the 179 total, well, that's a relative frequency of 0.17 because I'm taking the 30 divided by the 179. The probability of a 20 to 24-year-old buying an iPad Pro in the year is 17%. So if you're doing a marketing plan or something like that, understanding the relative frequency of how your customer segments are buying and the number of units that they're buying, that could really drive some important decisions on where your budget should go. We'll be looking at some of those examples as we go on. So here in this example, we're going to use the subjective method. So I'm going to have some information here that was already known. Perhaps I knew in the year that we sold 179,000 units of iPad Pros in the year. And I might know something about my customer segment, but there's something missing here. I don't have any frequencies here, right? How am I going to get these frequencies? Well, maybe I could use my judgment. I have been working in the industry for many years, and not only have I been working at this company, I know something about the way that the general market goes with these different age segments. And so I might start with plugging in some relative frequencies just for this group. And so I might come up with these, and I would say, well, in the 0 to 19 age group, the relative frequency of them buying is probably only 10% or 0.10. And I'd have to do that for every segment. So long as this adds up to 1.0, I can use the relative frequency method to do something maybe obvious now to you, but I can intuit this backwards to actually look at the number of units that are expected to be sold to each of those age groups, which is what I've done here. So I've really intuited this, everything in blue here, based on my industry knowledge. But based on that, and just knowing the total number that I actually do sell in the year, I can use the math here and say, well, if the relative frequency is 0.10, that times the 179, I can actually expect 17.9 thousand units to sell to 0 to 19-year-olds and 35.8 thousand units to sell to the 20 to 24-year-olds. So the point is that because it's multiplicative and works backwards and forwards, you're able to use information, sometimes limited information, such as an average or a total sold in different age segments, to then calculate relative frequencies and even volume. A lot of times you won't see in newspaper articles or news or anything on the web information like this, but it's very common to see some kind of total of something happening, and then you can intuit the different age groups that might be actual segments and then back into all these numbers. And that might make you the star of the show at your next staff meeting. So based on the relative frequency here, we're expected to sell 17.9 or 17,900 iPad Pros this year, again, to customers in the 0 to 19 age group. Just repeating what I had in the last slide with a little bit more fidelity.